In early 2025, subtle but significant geological changes beneath Colorado's San Juan Mountains began raising concern among scientists. Initially, these disturbances took the form of low-frequency tremors detected by seismic equipment near the long-dormant La Garita caldera, a site that last erupted nearly 28 million years ago. Though these vibrations were imperceptible to human senses, they caught the attention of geologists familiar with the region's ancient volcanic history. What was at first considered routine tectonic activity evolved into a series of patterned rhythmic tremors. These were classified as harmonic tremors, which are usually associated with magma movement. What truly elevated concern, however, was data obtained from NASA's INSAR satellite system, revealing that the caldera floor was not just shaking, it was slowly rising. Initial uplift in the caldera floor measured in millimeters, a small but worrisome movement in geological terms. At the same time, lateral shifts were noted, indicating multidirectional pressure beneath the Earth's surface. These signs prompted the U.S. Geological Survey and the Colorado Geological Survey to collaborate on a more extensive monitoring effort. They installed ground-based instruments such as borehole seismometers, geochemical gas sensors, and tilt meters to detect ground deformation more precisely. The data gathered over several weeks confirmed that the crust was indeed under increasing stress. Surface bulging was visible along certain trails and old service roads. Cracks once attributed to natural erosion were reclassified as pressure-induced fractures. Wildlife behavior in the area added an eerie layer to the evidence, with herds of elk and deer abandoning their usual grazing spots, while bird migration patterns showed unexplained alterations. Looking back through historical imaging and satellite archives, scientists found that these changes were not entirely new. The deformation had begun slowly, subtly, over the last several years. However, the speed and intensity had escalated dramatically in 2025, surpassing all thresholds that would trigger alerts in monitoring systems. Subsurface imaging uncovered that magma chambers once thought to be long cooled were showing renewed activity. Thermal scans displayed unusual hotspots forming under previously dormant lava domes. The use of infrared cameras helped identify steady increases in ground temperature across fault lines and fissures. These increases were uniform, suggesting a centralized pressure source likely emanating from a reawakening magma body. Chemical analyses of the region's soil and groundwater presented more troubling revelations. Samples contained elevated levels of volcanic minerals like olivine and pyroxene, typically formed in high-temperature conditions. These minerals were not previously present in the area's topsoil, implying fresh volcanic activity deep below. Gases emitted from the ground included a surge in carbon dioxide and a growing concentration of sulfur dioxide, both classic indicators of magma nearing the surface. Perhaps most alarming was the detection of helium-3 in groundwater samples, a rare isotope usually found only in the Earth's mantle. Its presence indicated a powerful geological force originating from deep within the planet, not a shallow crustal event. This combination of seismic activity, thermal anomalies, and geochemical evidence suggested a system that was transitioning from dormancy into a potentially active state. In the national forest surrounding the caldera, visitors began noticing strange phenomena. Compasses became unreliable in certain areas, reacting to localized magnetic shifts. Campers reported unexplained heat radiating from exposed rocks even during cold weather. Forestry workers described steam venting from the ground, accompanied by a sulfuric odor. Rangers patrolling backcountry trails found new cracks in previously stable terrain. Vegetation near these fractures showed visible stress. Plants that had once thrived were now wilting, browning, or dying without clear external cause. Atmospheric sensors added a final piece to the puzzle, registering slight increases in particulate matter above the region. These particles resembled volcanic ash and aerosols, even though no visible plume had formed. The presence of these microscopic materials hinted at deep-seated volcanic leakage, where gases and fine ash were being expelled in quantities too small to be noticed by the naked eye, but significant enough to be detected by scientific instruments. All these factors, ground deformation, gas emissions, heat anomalies, and ecological responses, coalesced into a disturbing picture of geologic unrest. As scientists compiled the data, a growing number became convinced that La Garita might not be as dormant as previously assumed. The consistent findings across multiple disciplines suggested a cohesive underground process. It wasn't just one anomaly, but many, all aligning to indicate that magma was not only moving, but possibly ascending. This upward movement created pressure that was reshaping the landscape from below. Tilt meters placed on opposite ends of the caldera confirmed symmetrical expansion, meaning the entire area was stretching, not just in isolated pockets. This type of deformation is typical in volcanoes, where large magma bodies begin to swell as gas and fluid pressure increases inside them. Even more compelling were the results of the high-resolution radar scans showing that the caldera's subsurface structure was changing. Cavities within the ancient magma chambers that had solidified eons ago were becoming active once more. As heat and pressure increased, they began to liquefy surrounding rock, expanding pathways through which magma could travel. This reactivation process suggested a geological mechanism that had been building slowly, possibly for decades, but was now accelerating due to a critical threshold threshold being reached. Unlike sudden eruptions triggered by earthquakes, these changes hinted at a prolonged buildup, one that might culminate in an event of catastrophic scale if left unchecked. This possibility sparked debate within the scientific community about what course of action should be taken. Some advocated for immediate public advisories and restricted access to sensitive zones, while others warned against inciting panic based on incomplete data. Nonetheless, emergency response teams began discreetly preparing contingency plans, identifying evacuation routes, and coordinating with local governments. In parallel, geological teams expanded their instrumentation networks, adding deeper boreholes and deploying aerial drones equipped with infrared imaging. These drones surveyed the landscape continuously, searching for new thermal anomalies, gas plumes, or signs of surface deformation that had been missed by ground crews. New data continued to pour in, reinforcing the hypothesis that magma intrusion was intensifying. Gas concentrations spiked once more, especially in areas closest to the ancient eruption's epicenter. In some boreholes, the ratio of helium-3 to helium-4 increased beyond typical background levels, a near certain sign of deep mantle material forcing its way upward. This information lent weight to the notion that La Garita was not just stirring, it was actively preparing for a resurgence. As more fractures formed, particularly in the eastern rim of the caldera, geologists began mapping stress points, identifying regions most susceptible to future venting or fissure formation. The geological transformation was not confined to subsurface layers alone. Above ground, subtle but growing signs of instability became more pronounced. Small landslides occurred near areas of pronounced uplift. Water tables shifted, altering the flow of nearby creeks and springs. In some places, hot springs began emerging where none had existed before. These natural features emitted steam and gases, further confirming that heat was migrating upward. Even tree growth patterns began to change, with stunted or twisted trunks appearing in regions of new thermal activity. The landscape itself was adjusting to the forces rising beneath it. Public awareness of the situation remained limited during the early months of observation, but that began to change as independent researchers and amateur geologists noticed the accumulating evidence. Online forums and social media posts began speculating about the potential awakening of a supervolcano in Colorado. While officials attempted to control the narrative and prevent misinformation, the sheer volume of independently verifiable data made suppression impossible. News outlets began reporting cautiously on the situation, focusing on the scientific effort rather than worst-case scenarios. Nonetheless, the phrase supervolcano entered public discourse, reviving memories of Yellowstone and the massive eruption scenarios often depicted in documentaries and speculative fiction. Local communities, particularly those near the San Juan Mountains, began expressing concern. Tourism declined slightly as rumors of volcanic activity spread. Some businesses noticed a drop in bookings, particularly for backcountry camping and hiking expeditions. Meanwhile, researchers worked around the clock to analyze incoming data and refine eruption models. New simulations based on current pressure levels and magma chamber volume suggested that if an eruption did occur, it could range from a slow dome building event to a more violent explosive eruption, depending on gas saturation levels and the speed of magma ascent. These findings were shared with emergency management teams under confidentiality agreements, while public statements remained conservative. Despite the gravity of the situation, some scientists reminded observers that geological processes unfold over extended periods. The presence of magma alone did not guarantee an imminent eruption. However, the convergence of thermal, chemical, seismic, and ecological indicators left little doubt that Colorado's ancient volcanic heart was undergoing a fundamental shift. Preparations, both scientific and logistical, continued under the assumption that early warnings could buy time, even if the timeline remained uncertain. Monitoring stations were reinforced, and data sharing protocols were updated to ensure real-time access for global volcanic observatories. One particularly ominous development involved the steady increase in microfractures radiating outward from the caldera's center. These fractures, while small, indicated that internal stress was not only increasing but redistributing across a broader area. Such patterns often precede the formation of new volcanic vents or dikes. Additionally, aerial infrared surveys revealed expanding geothermal zones with soil temperatures significantly above historical baselines. These zones corresponded with areas where surface vegetation had begun to die off, providing a visual cue to otherwise invisible subsurface changes. In regions where steam vents had emerged, the smell of sulfur lingered in the air, a scent that carried with it ancient memories of fire and ash. These vents, while not yet dangerous, represented the system's attempt to relieve internal pressure. Should this pressure continue to build unchecked, the likelihood of a larger surface breach would grow. Each day, the story of La Garita shifted from one of ancient history to pressing present-day reality, with the world watching closely as a once quiet mountain range hinted at the possibility of rebirth in fire and ash. As monitoring efforts expanded to include international collaboration. Data from Japanese, Icelandic, and Italian volcanic research centers provided useful comparisons. These institutions, familiar with their own volcanic challenges, offered insights into similar geological patterns and the potential for long-term dormancy to give way to sudden resurgence. While every volcano is unique, the similarities in uplift, gas emissions, and harmonic tremors helped refine Colorado's risk profile. Across the globe, geologists kept their eyes on the developing situation, knowing that nature's rhythms can be slow but unforgiving. The Earth was speaking through tremors and gas, through uplift and heat, and the message was increasingly clear. Something ancient was waking beneath the Colorado sky.